Wasabi, you guys. We have a very intimidating integral here with an intimidating sum with some binomial here. So let's go ahead and just kind of break this down now. I'm not a fan of combinatorics, so I cannot think this in a combinatorics way. So instead, I'm just gonna simply break this up by using the definition of that whatever this binomial thing is. And so the way this is defined is n plus 3 factorial, n factorial, and then 3 factorial here. That's a very bad factorial sign. X to the power of n dx. And now this just simplifies. If you know your factorial algebra, right, the n factorial and n factorial is going to cancel out, so we'd be left with n plus 3, n plus 2, n plus 1. Yeah, that's it. And then we have like 3 factorial, which is 6, x to the power of n dx. All right. Now what? What are we going to do here? What are we going to do? We have what? X, and we have the sum. We don't know the sum of this is. If we just straight up integrate, we're going to be left with this nasty sum, and it's awful. It's god awful. We don't want to do that. We don't want to do that. Doesn't this look familiar though? Here, let me rewrite it like this. If you see something like this, what would you think? Ah, this is the derivative of x to the power of n, right? Now if I rewrite it like this, what does that look like? Ah, the derivative of x to the power of n plus 1. Now if you look very closely here, just focusing on this, okay, what does this look like? It seems like it's been derived like what, 1, 2, 3 times, right? So interesting. Let's kind of experiment with that. We know what we're going to do is we're technically going to construct a formula, a sum formula. We know that this is a geometric series. X to the power of n, what is this equal to? 1 over 1 minus x, right? Okay. Let's actually multiply both sides with x cubed. So we technically have x to the power of n plus 3. And this gives us x cubed over 1 minus x. Okay. And if we derive it, n plus 3, x n plus 2, you know, whatever the sum is. I'm too lazy to write the whole thing out, but you get the idea, right? This is a derivative of x cubed over 1 minus x. If we derive it again, right, n plus 2, x n plus 1, it's the second derivative, right? Okay, n plus 3, n plus 2, n plus 1, x to the power of n. This is our third derivative, right? So this is literally what we have. This sum is the third derivative of this function. Ah, okay. So what we have from 0 to half, 1/6, is this is the third derivative of x cubed 1 minus x dx. That's literally what we have. Okay, but dear God, this is nasty though, right? Do we really have to do third derivative? No, not exactly. When you integrate, we actually get the second derivative of x cubed of 1 minus x. And now you can go ahead, oh God, I mean, it's still nasty. However, what we can do is we could do polynomial division. Thankfully, this is just polynomial, geometric polynomial division. So you could literally just do the whole zero substitution thing, whatever. And so this is going to equal, so let me actually write it down like this, just for easier sakes. This is equal to what? Negative x squared minus x minus 1, and then plus 1 over 1 minus x, right? Very easy to calculate because it's a geometric polynomial division. So cool. So we can just write that down then. negative x squared minus x minus 1 plus 1 over 1 minus x. Okay. And now you can just go ahead and compute the, oh, don't forget that this is from 0 to half. So now second derivative, this is going to be negative 2x, negative 2. Okay. Ooh, okay, I think that's still good. This is going to be 0. That's two. Both of these terms are going to be 0. And then deriving this is going to be 2, 1 minus x cubed. Now, here's another thing I really like about this. This is just a constant. Constants, or they get absorbed by plus c, so this just goes away because that's just a constant, right? When you do antiderivatives, we get like the antiderivative plus c, whatever constant you have, it gets absorbed. And the reason why we do that, we take away the plus c, is because when we're calculating that 2, it's just going to cancel itself out, right? 2 minus whatever this, plug in whatever a half is, minus 2 minus plug in f0, and notice the the constant is just going to cancel itself out. That's why we just absorb the constant. So yeah, we can just ignore that too. So for those who think that that looks illegal, it's not illegal. You can absolutely do it. Okay, now I'm just going to take that 2, it becomes 1/3. Now we just plug in 1/2, that becomes 8. And then plug in 0, that's 1. So our answer becomes 7/3, just like that. Okay, I believe that's correct. Yeah, it is correct. Awesome. Alright, well there you go. 7/3. That is how you solve this integral very easily and quickly. Okay, so the hardest part is just you have to get used to constructing sums like this. Okay. This takes a lot of practice and experience. Alright, other than that, it should be easy for you. Alright, thank you so much for watching. I hope that helps, and I'll see you guys in the next video.